If you search online for laser security system, you will find lots of similar circuits and videos. All of them are pretty simple, but I think they all have one problem in common. They aren't really practical. See, in most of them you need one battery to power a laser diode and another one to power the sensor circuit and the buzzer. But since you probably want your laser sensor to be outdoors or next to the front door, firstly you will need to replace the battery with power supply and run two sets of wires from your room to the sensor. One for power and another one for the signal from the buzzer, because you obviously don't want the buzzer to be right next to the laser, but rather in your bedroom. Well, I have a simple solution for this issue, which uses just two wires for both power and detection signal from the laser sensor. Doesn't matter how far is the laser from the buzzer and the power supply. There are two parts. This is the receiver with the buzzer here, and this is the actual sensor with the laser diode here and the white dependent resistor here. When there's white on the white dependent resistor, this transistor here is always conducting, so we can say that this diode here is connected straight to the ground here. Second transistor works as a constant current source for the laser diode, and basically driving the laser diode. The voltage drop between the emitter and the base is around 0.65 volts, the same as the one on the diode. And since there are two diodes connected in series here, we have one more voltage drop which is present on this resistor, and that's actually the current running through the diode, because there's straight path from the diode through the transistor and this resistor to ground. So depending on the value of this resistor and the voltage drop, which is constant around 0.65 volts, we can calculate the current running through the diode. So in my case the current is around 8.5 to 9 milliamps, and if there's no light on the photoresistor, then this transistor turns off, and now we have one more diode drop here. So one more diode drop will be present on this resistor. Since the voltage is doubled now here, the current through the laser diode is also going to be doubled. I have the two wires running here, 15 meters in my case, and here's the receiver circuit. On the negative rail I have this 47 ohm resistor, which works as a current shunt, and if the voltage here is higher than 0.6 volts, then some current will start to pass through the base of this transistor and it will start to conduct. When it starts to conduct, it will charge this capacitor here and also power the buzzer and the LED. Then if the object is removed from the LDR and the current drops, then the stored energy in the capacitor will power both the buzzer and the LED for a few seconds. I made the circuit on a breadboard to see if the theory matches with reality, and seems like it does. Notice how the current on the multimeter changes as I move the piece of paper in front of the sensor, and the red LED reacts to that. I installed the laser and the sensor on the walls of the stairs, and I run a twisted wire upstairs to get to the receiver with the buzzer together with the power supply. I added a switch on the buzzer so I can switch the sound off or on if I want. And for the power I use a regulated 9V supply. Now let's see how it works in practice. If something passes through the laser beam, the laser current increases and the receiver detects it and buzzes the buzzer for a few seconds, then it goes back to normal. There are a few upgrades that can be done. The first one, I connected a reed switch in series with the LDR. This is one more way to trigger the alarm. I put it on my front door and added a switch on it so I can turn it on or off. This way I will know when someone opens the door or when they get upstairs. In my opinion, this is a pretty handy upgrade. The system can be made unnoticeable by using an infrared laser instead of the red one, but since it's normally barely lighting the diode, I like it more this way. It's cool to see in the dark how the laser fires when something blocks it. And actually I really like playing with it, even though the noise is quite unpleasant to hear.